Okay, in this video we are going to talk about relations. So in the previous video we saw how sets are defined and represented. We are looking at relations now in which elements from two sets are related. So how it happens is that suppose we have a set here, and that set is a set, let's call it A, and another set is a set B. So we might have it like that, that this set has got some elements here, could be anything. I'll just show them with points here, and these elements, some of these elements are related, or basically they are mapped to some other elements in set B. Yeah, so we have this getting mapped to that, this one getting mapped to that, this one getting mapped to that, and that one getting mapped to that. Now what we are seeing here is a graphical or pictorial representation of a relation. Yeah, so what is a relation? Relation is, I think I better write it, because I'll type it so that it's more clear. So suppose there are two sets, A and B. The members of A, just like we have shown here in the pictorial representation, the members of A are, we call it linked or mapped, or we can use any of these words, related to elements of the set B. Okay, so this is what we have shown there. So what we define, so let's give it a name. As we define the relation R from A to B by making, okay, it should be not from A to B, basically. Bear with me. Relation R from A to B by making a set of these pairs where the first element of pair comes from the set A, and the second one coming from B. So what we are seeing here is that we got first, this is nothing but set, these are nothing but pairs. So we got one pair in which this is one element, that's another element. Then we got the second pair, this is the first element of the pair, and that's the second element of the pair. Then we got the third pair, and like this. And a set of all these pairs is basically our relation. Yeah. So I can basically, not here, or I'm not writing here, I'll write it here, and these things will become clear when we look at an example. So the relation R from set A to set B is a set of ordered pairs. Yeah. And why do we call it orders? Because the order is important. We cannot reverse the order of elements in these pairs. Let's look at an example, and I think that will make things very clear. So let's define it like this, that we have a set called A, and it has element 1, 2, 3, 4, 5, 6, and 7. And then we have another set called B, which is 1, 2, 3, 4, 5, and it goes up to 12. Now I'm defining relation R. Yeah, so R is equals to, as I told you, it's a set, and it's a set of pairs. So I'll say set of pairs X and Y, such that Now here I'm defining the relation, so I'm saying that's y is equals to 2x minus 1. But then I also need to tell where my x and y is coming from. So I say x is a member of A and y is a member of B. You can already see that you are on the familiar ground, because I did not mention it earlier, but you can see that first element is always denoted by x, and second element is denoted by letter y. So this basically describes a relation, and we can make a list of, we can represent this relation in the roster form as well. Now this is SetBuilder form, right? This is the SetBuilder form. In the roster form, all we need to do is we need to pick up values of x and find the values of y. So r could be very well represented as, so first value of x I take is 1, then y is also 1. Second value of x is 2, and the y that we get is 3. Next one is x is 3, put here in x equal to 3, and y you will get as 5. 4, you get x equals to 7. 5, you get 9. 6, and you can get 11. After that, if you put x equals to 7 there, you get y equals to 13, which is not in the B. You won't find this in set B, because this second value is coming from set B. Yeah, so first element is coming from set X. This first element is coming from set X, and second value is coming from Y, as written here. So this is my set in the roster form. Very easy. So now you can see that we have represented this set in the we have represented this relation in the SetBuilder form, and we have represented this relation in roster form. You can represent this in many different forms as well, and I think you'll be finding yourself on familiar ground if we represent this thing in a graphical form. We have the first element is x and second element is y, and we have done graphing of x and y elements in year 4, 5, 6. So this is my x, this is my y. I think you are already feeling comfortable with this. So first value is this, and then this is 1, 1 coming from here. Then it goes up to 6, 12 here. So that's what I have, 6, 12 here. Now some of you might say that this is not right. So I'm saying this, what I have drawn here, what I've shown here is not right. Can anyone tell me why it is so? I want you to pause the videos for a moment and ask yourself why this is what I've shown here is not right. This relation that I've shown here on the graph here in the graphical form is not right. Well, what you see here is, here the graph shows that all the values of x and y between 1, 1 and 6, 12 are included, which are basically, we are saying that they are real numbers here. Whereas my set, my relation, has elements which are discrete. So this is not right. If I want to show my relation properly, it would be like this. It will be discrete values, 1, 1, 2, 3, 3, 5, like that. Let me clean it up a little bit and show it properly, so that that's my x, that's my y. So first value is 1, 1, 2, 3, 3, 5, 4, 7, 5, 9, and 6, 11. Now this is the correct representation of my relation that I have shown here. If I ask you to show this relation, how would you show that in SetBuilder form? again, I want you to pause the video and try to show this relation in SetBuilder form. Yeah, and SetBuilder form is, you can just pause the video and you can look here, and I'm going to write here the SetBuilder form. This relation R is equals to, I'll need to define my A and B as well, redefine my A and B as well. So A will be, A consists of X such that I need to look up, I need to scroll a bit up there and see what we got here. A is from 1 to 7, so I need to include all the values there. A is equals to, and that's from greater than equals to 1, less than equals to 7, and I don't need, if I don't say it is R, it is still assumed to be R. And B is my, I define as Y with my values from 1 to 12 if I believe correctly. So Y less than equal to 1, Y greater than equal to 1, and Y less than equal to 12. Again, Y is R, and now I can define my relation R. I say that X comma Y such that Y is equals to 2X minus 1, and I say X is coming from A and Y belongs to B. These definitions here represent this graph shown here. Incidentally, I should also mention here that this relation that we have shown here, it can also be normally shown like this. It's R is a relation from A to B. That definition, that kind of notation is also used many times. Now we also need to see a few more terms here. I think we can also look at, we looked at the SetBuilder form here, we looked at the roster form, we looked at the graphical form here, and there is a arrow form as well. So I'll just do an arrow form here. So the arrow form, it is nothing but it shows again pictorially the relations between elements of the two sets. Yeah, so what we're going to do is I'll draw these two sets here. So I know that that's my set A and that's my set B, and I know that my set has got elements 1, 2, 3, 4, 5, 6, and 7. And here in set B, I got elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I know, as I noted here in the roster form, that 1 maps to 1 here, 2 maps to 3, 3 maps to 5, 4 maps to 7, 5 maps to 9, and 6 maps to 11. And that's the arrow form of relation R. Pictorial presentation, and it tells you what elements are related to what. Now we need to also look at a few definitions. So first definition is domain. I think I'll type it up because it will be easier to read. So domain of set relation R. So domain of relation R is the set of all the first elements of the ordered pairs. Yeah, so all the first elements of the ordered pairs. So you can look in the roster form, or you can look in the arrow form as well. And I think I can write it here that domain of R is a set of all the first elements. So first element is 1, 2, 3, 4, 5, and 6. Yeah, you can see that 7, although is a member of set A, it is not in the domain of R. Next definition is range of relation R. So let me again type it up. Range of relation R is the set of all the second elements of the ordered pairs forming the relation R. So again, the second elements only, so I can write the range of this relation here. Range of R is equals to, I got 1, 3, 5, 7, 9 and 11. And the last definition that we are going to write is the domain, codomain. We got the domain already. So codomain relation R is the complete set B. Yeah, the whole set B here as shown in this arrow diagram. This here, that is the codomain, and we can obviously see that range will always be a subset of codomain. So we can write it like this: range is a subset of codomain. I think here I must also differentiate between two kind of subsets. So one type of subset is the proper subset. So this here shows the proper subset here, and a subset in which the both the sets may be equal is shown in a different manner. So let me show that with an example. So I draw like this. What it means is the range will always be less than codomain or will be exactly equal to codomain. So this symbol takes care of both the eventualities. One eventuality is that from when you take the range, some elements from the codomain will be missing, and then it's this proper subset. But this is also possible that range and codomain are exactly equal. In that case, so this symbol basically covers the second eventuality as well. And we finish here, but you need to work on an exercise. So this is an exercise I have here, and it's a simple one, just a little bit of practice on how sets are formed and how relations are formed, and then you need to write about domain and range and other things. So give it a go. It should be easy.